what this node 1 signify. Okay. Okay. Nodes 1 signify what we call as joint probability of Sachin playing and India winning. Can I say that in node 1 we are saying that Sachin is playing and also India is winning. Okay, so what we have is we move this tree. Okay, from here we started, we are coming over here, probability that Sachin is playing, so PS, Sachin is playing. Okay, and we move over here, that probability that India is winning given Sachin is playing. Okay, so that means in Sachin has played, okay, and you have come over here, and then India has won. Okay, so from here what has happened is Sachin has played certain, okay, and here to here India is winning. So we can say that this node means Sachin has played and also India has won. Okay, so this is trying to signify joint probability of Sachin playing and India winning. Okay, so we can say this as probability of Sachin and playing and India winning. So this node 1 signifies Sachin playing and India winning. Now for this joint probability, okay, so we have a rule which is called as multiplication rule. So we have multiplication rule for these joint probabilities. In this multiplication rule, what we say is when the events are conditional, okay, when the events are conditional, this is written as probability of S, because S is unconditional, so probability of S into probability of India winning given S. So this is a multiplication rule, that is we have multiply over here, probability of S into probability of India winning given S. Okay, so probability that Sachin is playing into probability that India winning given Sachin is playing. So if you see what is the probability that you see in the node 1, what is the probability of node 1 happening? The probability of node 1 happening will be equal to 0.8 into, can I say 0.7? Probability of node 1 will be 0.8 into 0.7, which we will say as 0.56. So the probability that India will win and Sachin will play is given as 0.56. Okay, so this is what we call as joint probability. So this is referred as your joint probability of Sachin playing and India winning. So joint probability, when you have, it is used through multiplication rule. So you have joint probability, we will use multiplication rule. Okay, so this is a multiplication rule when you have conditional events. So this is a conditional on this. However, you can have some independent events also. So this is only for conditional event. You can have independent events also. So for independent events, okay, so let's say there is one independent event like Ponting playing. Okay, probability of Ponting playing is 0.8. Probability of Sachin playing is 0.8. Assuming that both of India and Australia are not playing each other. So Australia is playing Bangladesh, India is playing with Sri Lanka. Okay, so these are independent. That is probability of Ponting playing, probability of Sachin playing is independent of each other. So what is the probability that Sachin and Ponting both will play in a match? Okay, this will be given as probability of Ponting playing into probability of Sachin playing. Please note that there is no conditionality over here. So this will be given as 0.8 into 0.8 or 0.64. Again we have this multiplication. So whenever you see and, okay, whenever you see and, think about multiplication. You have to multiply one with the other. Okay, so probability is, so whenever you have and, so it is multiplication. Okay. So same way we can say that, okay, what is the probability that Sachin will play and India will lose? Okay, which node we should refer to? So if you see Sachin is playing but India is losing. Okay, so the node 2 is referred as Sachin plays and India lose, or sorry, India doesn't win. Okay, now it may happen that India win even Sachin is not, when Sachin is not playing. So over this node 3, if you see Sachin is not playing, India is winning. So Sachin is not playing, India is winning, we have node 3. Okay, Node 4 is Sachin is not playing and India is also not winning. So that is node 4. Okay, so we can find out the same way the probability of all of these nodes. So the probability of this node 1 will be just multiplication of this 0.8 into 0.7, which we have found it to be 0.56. So that's the probability of node 1. If you want to know find out the probability of node 2, it will be 0.8 into 0.3, so it will be 0.24. What is the probability of node 3? It will be probability of Sachin not playing 0.2 into India winning given Sachin is not playing. So 0.2 into 0.4, it is 0.08. Okay, so this is the probability of node 3, and this node will be 0.2 into 0.6, 0.12. Now if you take the summation of this 0.56 plus 0.24, it will be 0.8, which will be equal to this. So 0.56 plus 0.24 will be equal to this. 0.08 plus 0.12 will be equal to this. Okay, and if you take the summation of all these four, this plus this plus this plus this should be equal to the summation of this and this, or I can say as 1. So summation of this and this should be equal to 1. Okay, so what we have is we have joint probability of an event is being denoted as multiplication rule, and we use cross multiplication sign for that. Okay, so multiplication rule for joint probability of two events. Joint probability is that two events will happen together. Joint probability of conditional event is given as P A and B is A given B into B. Okay, that is, this is A is dependent or A is conditional on B. Joint probability of independent event is given as, there is no condition over here, so it will be A into B. Okay. However, if there are more than two independent events, when there are n independent events, you can say that probability of A1, A2, AN, okay, it will be given as, so these are all A1 and till AN are independent, so we can say that joint probability will be A1 into 18, A2 till AN. Okay, so whenever you are seeing AND, please note that you should be using multiplication rule. Now let us try to consider the addition rule of probability, or it is also like OR rule. Okay, so we'll consider in the next example addition rule, total probability, and we will consider also another rule which is called as Bayes theorem. So let's try to cover that. So we'll go through the same example. Okay, that is Sachin playing. Okay, probability Sachin playing. Okay, given as 0.8. Okay, then India winning given Sachin is playing is 0.7. Okay, and probability Sachin is not playing, and probability India winning given Sachin is not playing is, we have found out it was 0.4. Okay, this is 0.2. Probability of India not winning given Sachin is not playing was 0.6, and probability that India not winning given Sachin was playing was 0.3. So we had node 1, 2, 3 and 4. Okay, now I ask one question to you. Okay, what is the probability, okay, that India will win or Sachin will play? So I'm asking you the probability that, okay, so before that, sorry, before that I want to ask you one probability. What is the probability that India will win? Okay, so can you give me the probability that India will win? Okay, so before that, like, you can tell me like which node India is winning. So where all India is winning, if you consider this diagram, where all India is winning, can I say that in the node 1 India is winning? Also in the node 3 India is winning. So India is winning over here, India is winning over here. So these are the two nodes that India is winning. So if I want to know the probability of India winning, I will write the probability of 1 and probability of 3. So that is, and means over here like not multiplication, that is either India is winning in node 1 and this node 3 1, so there will be a plus over here. Okay, so I can find out the probability. So we have found out the probability earlier, it was 0.56, and this we had find out the probability was 0.08. So we can say that the probability of India winning will be equal to 0.64. Okay, so this is the probability that India is winning. Okay, Now I ask you, what is the probability that Sachin is playing? We know that, right? Sachin, the probability of Sachin playing is 0.8. Okay. Now I ask you the question, what is the probability that India will win or Sachin will play? So I want to know what is the probability that India will win or Sachin will play. So if you think from the set perspective, from the Venn diagram perspective, what we are saying is, okay, probability that Sachin will play, okay, if it is represented by this circle, this is a universal set, okay, and probability that India will win, okay, it is happening sometime that Sachin and India winning is coming together. So that is, it is happening sometime that Sachin is playing and India is winning is happening. So if you see, what is the probability? Sachin is playing, also India is winning. We have computed it to be 0.56. Okay. We have also computed the probability of India winning. The probability of India winning we had computed, it was 0.64. Okay. We had computed the probability of Sachin playing as 0.8. Rather, it was given. Now I want to know what is the probability that Sachin will play or India will win. Okay. So we are concerned about this. So if you think from, we are concerned about this particular set, this entire S, and now we have covered this S, so I want this part. Okay. But if you add this, if you add for India winning or Sachin playing, if you add this PS plus PIW, what is happening is S is this complete set, IW is this complete set. So what is happening is this item is coming twice. So you have to deduct when Sachin is playing and India is winning. So if you want to find out, that will come as probability of Sachin playing is 0.8 plus this is 0.64 minus when both are is 0.56. So the answer will be 0.88. Okay. That is when Sachin is playing or India is winning is 0.88. Okay. So that is how we can represent. But let's see from the tree diagram perspective where all it is happening. So Sachin is playing in node 1. Sachin is playing in node 2. So this and this is playing, Sachin is playing. Okay. And if you see this node 3 is a place where India is winning. So India is winning here and here. Sachin is playing here. Okay. And as a result, what we can say is, when you are saying probability India will win or Sachin will play, can we write as it will be 1 plus 2 plus 3. That is the probability of node 1 plus probability of node 2 plus probability of node 3. Now if you see 1 plus 2 is this 0.8. We have seen that 0.56 plus 0.8 into 0.34. This probability is 0.24. So 0.456 plus 0.24, 0.8 plus this node probability is 0.08. So the probability is 0.88, which comes as the same as what we have computed through this. Okay. So probability of, in case of two events, when we are asking about probability of A or B, it will be given as probability of A plus probability of B minus probability of A and B. Okay. Note that this formula is applicable for both conditional or independent event. Okay. Now you know that for conditional event this will take a different form, for independent this will take a different form, but this formula of A or B is remaining true for both the cases. Now so addition rule of probability we know. Now what is total probability? If you see, we had computed the probability of India winning. Okay, the India winning probability was computed through node 1 and node 3, the summation of node 1 and node 3. Okay, so what we are saying is, this India winning we have found by adding the node 1 and node 3. So if you I will again put it okay, so let's see again over here. Okay, so we had, I'll just draw the diagram fast. Okay, we had Sachin playing, okay, India winning, okay, Sachin not playing, and you had India winning. So we know that India is winning in node 1 and node 3. Okay, so what we say is over here when India is winning, the probability is conditional. Why it is conditional on Sachin playing? Here it is conditional on Sachin not playing. Okay, so whenever you see node 1 and node 3, you know that something conditional is happening. Okay, when I add the node 1 and node 3, what is happening is, if you see node 1 and node 3, it doesn't matter whether Sachin plays or not plays. Okay, India is winning. So that means the probability of India winning is now not conditional. Okay, it is unconditional. So, and since it is obtained by adding node 1 and 3, so this unconditional probability is also known as total probability. So unconditional probability is also known as total probability, wherein you are saying that you are taking the sum of 1 and 3. Okay, so here if you see, no matter what will happen, Sachin plays or not play, India is still winning when you have added these two. Okay, so the probability is unconditional or total. So if you see the PowerPoint, what you have is total probability. It is also called as unconditional probability. So unconditional probability, it says that occurrence of the event given unconditional probability. So what we have is, okay, let's say A1 signifies that probability of A given B1. So what you have is, you have a case wherein you have B1, B2 till Bn, there are n events. Okay, and over here A given B1, so A given B1 we signify as PA1. Okay, you have A given B2, you signify as A2. So the probability of A occurring is summation of A1 plus A2 plus A3 till n. Okay, now PA1 is probability of it should have been A given B1. So PA1 is A given B1 into PB1. Okay, probability of A is then written as probability of A given B1 into B1 plus probability of A given B2 into B2 till A given Bn into Bn. Okay, so we have till now seen only two cases. Okay, but here we are like generalizing the case for n numbers. Okay, so for n events we are generalizing that the total probability or unconditional probability is given as this. Let's try to understand one more rule. By the way, like in FRM, like they have not explicitly said that you have to know a rule which is called as Bayes rule. Okay, but you are required to understand Bayes rule, because in the past they have had asked tough questions using the Bayes rule. So one tough question will be covering, but let us try to understand the Bayes theorem. Okay, so Bayes theorem deals with the updated probability. Okay, it deals with the updated probability. So take the same case, okay, that is Sachin is playing or Sachin is not playing. Okay, let's say you are a cricket fan. Okay, and what you are seeing is, you are a cricket fan, right? Now let's say you wanted to see the match, you wanted to keep track of everything. Okay, but unfortunately because of your office work, you are not able to keep track of whether Sachin is playing or Sachin is not playing. Okay, you are not able to keep track. But like in your office, like you got to hear from some person that, let's say, India won the match. Okay, so you got to know from one person that India won the match. Okay, what would you think? Okay, let's say you had earlier thought of, okay, so he had earlier thought of, okay, India has, now he has thought of India has won the match. Okay, you know that India has won the match. So you would think that most probably like either Sachin would have you would have think that Sachin would have played, because what was happening is you had evaluated that if Sachin is playing, the probability of India winning is more. Okay, now think of, you have got a news that India has won. You did not know that whether Sachin was playing or not. Okay, so what you will try to summarize, you will, whenever any updated news has come to you, you will try to think in the in like updated news item, what would be the impact. So I will just try to draw the same diagram which we have seen and try to understand using the tree diagram this approach what I am saying. Okay, so here Sachin was playing. Okay, you had said that the probability that Sachin will play is 0.8. So you had assumed it, but you did not know whether Sachin was playing in the match or not. Okay, and India winning given Sachin was playing was given as 0.7, right? And let's say take this case, Sachin was not playing, which you know is mutually exclusive, so 0.2. Probability that India winning given Sachin was not playing was 0.4. Okay, so this was the scenarios. Okay, now what you have got the news is that India has won. So you have got the news that India has won. That means if India has won, that means either 1 would have happened or 3 would have happened, because in other 2 cases India was not winning. So either of these 2 was possible. That is either either this node 1 has happened. So that means either node 1 has happened or node 3 has happened. Okay. Now if you see what is the probability of node 1 happening, 0.8 into 0.7. So the probability of this node happening is 0.56. What is the probability of node 3 happening? 0.2 into 0.4, which is 0.08. So the probability of node 2 happening is 0.08. Okay. Now when you think that when you have got this news that India has won, what would you conclude? Would you conclude that 3 would have happened mostly, or would you conclude that the chances of this happening was more, so most likely that node 1 has happened? Okay. Now when node 1 has happened, it means that most likely Sachin had played in the match. Okay, when node 1 has happened, that means Sachin has played in the match. Okay, so what you are trying to find out is Bayes theorem is related with the updated probability. So you have got the news that India has won. Okay, now you want to find out what is the probability that Sachin played in the match. Okay, so please note that when you have this news that India has won the match, the probability that Sachin will play in the match, will it remain as 0.8 or will it change? My question is, will it remain as 0.8 or will it change? Okay. Please note that 0.8 probability is known as what is called as priori probability. Priori probability is before the fact. You do not have any information. Okay. Whereas Bayes theorem deal with updated probability, or it is also called as posterior probability, that is after the fact or after the event has occurred. So after you have known that, after you know that India has won the match, okay, will the probability of Sachin playing remain as 0.8? No, it will not. So what will happen is, what you will say is the probability of this node happening will be more than this probability of this node happening. So if you see what was the probability of India winning, the probability of India winning was 0.64. Okay, the probability of Sachin playing, so what we are interested in knowing is this now, probability that Sachin will play given India has won. Okay, so we are interested in finding out probability that Sachin has played given India has won. Okay, so first of all let's see this. What is this probability of, what is this probability of India winning given Sachin has played into probability of S? Can I say this is probability of India winning and Sachin playing both, the multiplication rule? Can I also say that probability of India winning and Sachin playing can be written like this? Can it be written like this? Can we say that probability of India winning and Sachin playing is probability India will win given Sachin has played into probability of Sachin playing? The same thing can be written like, because we are interested in finding out what is the probability that Sachin has played in the match given India has won. Okay, so it can be written like this. So what you can do is you can equate these two and come up with the equation for it, so which I have given in the PowerPoint. However, I do not want you to solve using this method. Okay, using the formula I do not want you to solve, because you will get confused. Okay, what I will say is, when you want to solve this problem, that is what is the probability that Sachin has played given India has won. Okay, so think about it. India can win here or here. Okay, in which case Sachin is playing? Sachin is playing over here. So what we have is, if you remember that probability can also be thought of, probability is equal to, if I write over here, probability of any event is given as favorable outcome divided by total outcome. So favorable outcome divided by total outcome. What is the favorable outcome? Favorable outcome will be here 0.56 because Sachin is playing in this node 1. So my favorable outcome will be 0.56. What will be my total outcome? Total outcome will be summation of 1 and 3, 0.64. Can I say that? So my total outcome is 0.64, summation of 1 and 3. My favorable outcome is 0.56. So I can say that probability of Sachin playing given India winning is 0.56 divided by 0.64. Okay. If you see this, I can write it also. 0.56 can be written as 0.7 by 0.64 into 0.8. Remember, it can be written 0.56. How it came? It was multiplication of this 0.7 with 0.8. So 0.7 into 0.8, okay, in divided by 0.64. This is how we wrote. Okay. Now if you try to simplify this equation, so can I say that this will be equal to this? Can I say that these two will be equal? Okay, because both are doing the calculating the same thing, that is probability of India winning and probability of Sachin playing. Both are the same thing, right? Can we say this? So if you try to simplify this, what we can see is probability that Sachin is playing given India has won will be equal to probability India won given Sachin was playing into probability of Sachin playing divided by probability of India winning. So if you equate this into this is equal to this into this will be this into this divided by this. So probability of India winning given Sachin played, India winning given Sachin played 0.7 into probability of Sachin played 0.8, probability of Sachin divided probability of India winning 0.64, probability of India winning. Okay. So Bayes theorem, I would say that you should solve using the tree diagram if at all it comes in the examination, and please note that there is a very high probability that it will be coming in the examination. So 1 mark is sure for you, and that is the Bayes theorem. Okay. Now I will give you one question. It is slightly difficult. Okay. Now you have to analyze from the wordings of the problem. Okay. You have to analyze from the wordings of the problem. Okay. That is how to draw the tree diagram. Okay. My hint over here to understand how to draw the tree diagram. Okay. Whenever, so the question here was, if you ask me the probability, this Bayes theorem, the question was, what is the probability, okay, that Sachin played, this is the question, that Sachin played given India won. Okay, this was the question, what is the probability that Sachin played given India won. Okay, so whatever is given to you, given India won, okay, so India winning or India not winning should be on the second, that is the right side. That means if you see this is first path, okay, either Sachin playing, not playing, India winning, not winning. Now they have given you India has won. So whenever they have given India has won, India has won should be on the right side, and whatever they are asking you to determine, that is Sachin played should be on your left side. Okay, it will become clear. Okay, I will give you this question. It is a difficult question. I would want you to attempt this. Okay, so the question says, the question is this: